The history of the phylogenetic tree of life is a long and storied one. Originally, views regarding the tree of life and the relatedness of species were fairly rigid. One example of this is the early 1800s version by Haeckel, showing an initial depiction of what the tree of life may have looked like. These trees of life were formed based on comparison, the relatedness of like individuals to like individuals, shared traits between species. Green grass and green tree leaves were seen to be related. And through this, an initial form of the tree of life was created. However, we then found we could look even deeper. The discovery of DNA by Watson, Crick, and Franklin was a monumental step both for the field of microbiology as well as the field of taxonomy. DNA allowed us to detect minute differences between populations, pooling them by the degree to which their DNA was similar or differed. These pools of similarity or dissimilarity based on the DNA evidence allowed us to recreate the system of classes, kingdoms, clades, species, genuses that we created previously from simple visual comparison of species. Through this, we are able to form the new phylogenetic tree of life. This tree of life diagram is a simplified one. If we zoom into Animalia, this contains the entirety of all animal species. In this example, deuterostomes are a subtaxon of the kingdom Animalia. We can see that as we move down and become more specific, it goes from deuterostome, which simply means two holes, to having a cranium, vertebra, jaws, lungs, four limbs, amniotic eggs, and finally producing milk, a hallmark of the mammalian class. Thanks to DNA, we can now see the complexity inherent in what had previously been seen as a simpler and more straightforward visual comparison diagram. Now that we have DNA as a tool to look into these deeper relationships, what will these new roots provide? Going from the old basis in Haeckel's and others' early trees of life to the modern phylogenetic tree, what will the future hold for the field of taxonomy?